I suppose when most people think about prisms, they naturally think of the triangular prism, partly because it's a very common shape. It's the shape of a tent, and you see hundreds of these on campsites, of course, and also partly because it's the shape that Isaac Newton used in, I think it was 1666, to separate white light into its component colours, and here's a wonderful little movie just showing that very point. So what is it that makes a prism a prism? Well, the characteristic feature of prisms is that this shape at the end, what we call the cross-sectional area, is the same all the way down. That is, it's the same shape and it's the same size. So if we take this lovely vase, for instance, great looking object though it is, it's definitely not a prism. Sure, it has a cross-sectional area which is a circle, and that will be the same all the way through, but as you see, the circle starts off larger, gets smaller and becomes larger again as we get towards the bottom. So it breaks the rule that the shape has to be the same size all the way down. Now, if we take a cuboid, that's obviously a prism because the cross-sectional area is a rectangle, and that's obviously the same all the way through. Now, some shapes are named after the area of the end, the cross-sectional area. In this case, as you can see, that's a pentagon. So we call this a pentagonal prism. And in this case, it's a hexagon, so this is obviously a hexagonal prism. But it doesn't have to be a shape that has a name. Here, for instance, is a prism which has a cross-sectional area shaped like a cross, quite relevant really, and that shape is the same and the same size all the way down to the far end. Now, one of the most common prisms, of course, is the cylinder, and here I have a rather large candle, and this gives me the opportunity to point out that in real life you very rarely find a perfect mathematical shape. For instance, in this case, it's got a flat end, that's great. It's a prism all the way up to here, but unfortunately right at the end there's a bit of a lump where the wick comes out. So you just have to sort of ignore those odd bits, the knobbly bits I call them, and just focus on the essence of the shape itself. Now let's take a look at this shape, and to be quite honest with you, I've got absolutely no idea what it is. I found this in my local garden centre, and instead of asking what it was, I just thought to myself, prism. Now if you look at it this angle, and you imagine cutting it this way and this way and this way, you're going to get different cross-sectional areas as you go through the shape. So you might think at first that it's not actually a prism. But this is where we need a bit of creative thinking. If we imagine that this shape, or this side I should say, has been painted white, for example, then if I cut it this way, we would get the same shape as here. And again and again and again until we get through to the other end. So this is actually a prism which has quite a big cross-sectional area for its size, but is only about 30 millimeters thick. Now I'd like you to have a look at this picture of a skip, or a dumpster as I believe the Americans call it. If you imagine cutting it from the left side, taking one cut and then moving a little bit to the right and taking another cut and then another and so on, the cross-sectional area will change as you move through. So at first sight you may think that that's not actually a prism. But if you imagine that the side facing us is the end, mathematically the end, you will see it's a trapezium. It has one pair of parallel sides. And then imagine cutting parallel to that, moving away from the camera to the back of the shape. I think you will see then that it will always be that same trapezium all the way through. So a skip is actually a prism too. Now, if you have a look at this road sign, is a road sign a prism? Well, it's triangular, and again, if you cut it starting at the left and moving to the right, or you start at the top and moving down, you probably won't imagine that it's a prism at all. But let's go back to my triangular prism here. Let's imagine that I cut a little piece off here, and then I cut some off here, and then I cut some off here. So the piece that's left is actually getting shorter and shorter and shorter, until eventually it's only 3 or 4 millimeters thick. That little bit left over will still be a prism, of course, even though it's a very thin prism. So most road signs, almost all road signs of this type, are actually prisms. But again, you have to identify the end of the prism. And in this case, it's actually the triangular face. And if you move through just a few millimeters before you get to the back of the sign, it's the same cross-sectional area all the way through. Now, so much is covered in mathematics lessons about prisms, you may well wonder why they're so important. Well, there are two reasons really. The first is that it's a good GCSE type of question. It enables the examiners to incorporate several ideas into one question. For example, if you were asked to find the volume of this particular prism, the first thing you would need to know is that the volume of a prism is the area of the end, the cross-sectional area, multiplied by the length. Now, because this is a regular hexagon, it would be natural to divide this up into 6 equilateral triangles, find the area of one of the triangles, and multiply by 6, and that will give you the area of the cross-section, of course. Then all you need to do is to multiply that by the length to get the volume. If you're dealing with the cylinder, then a cylinder, of course, has a circle as its cross-sectional area, so presumably you're going to be using pi r squared to find the area of that. And once you've worked out the area, again, the same principle, multiply by the length, and that will give you the volume. If it comes to a more difficult shape like this one, then it's very difficult to work out what the area of that end is, but you can do it. Do you remember when you were in primary school, perhaps you put this on graph paper, drew around it, counted the squares? Well, you can still use that technique, and that will give you the area, multiply by the length, and that will give you the volume. Multiply by the density of the clay that made this, and you'll work out its mass. The second reason is that prisms can be found all around us, and they're actually quite easy to manufacture if you happen to have a factory or two at your disposal. Every day, companies all over the world manufacture cylinders in the form of tin cans and candles, rods for fencing, concrete reinforcing meshes, etc. And here we can see hundreds of cylindrical posts put into the ground to stop people driving vehicles onto this green. You only have to open up your kitchen cupboards to find a great number of cuboids. Prisms are used in structures such as greenhouses and summer houses, and here you can see a large eye-shaped girder in the grounds of a factory on which a crane travels to assist in the moving of large loads. Prisms used to be used in the manufacture of steam engines, and are now used to collect hay together, for millions of road signs, as we've already seen, for lamp posts, concrete fencing posts, slates, piping of all shapes and sizes, drain surrounds, timber. The list goes on, and once you learn to spot them, you can be driven mad by them. They become like one of those songs that spins around in your head and just won't go away. Now, I've already said that prisms are easy to manufacture if you have the right type of equipment, and there are moulding machines with very high-speed cutters that can cut away surplus wood very quickly. And this first piece started life, obviously, as a very long cuboid, has been through one of these machines and shaped quite nicely and neatly into a handrail, the type that sits on top of a support here. The second one is another handrail, but this is the type that goes along a wall, perhaps in an old people's home, for example, so they can hang on tight as they walk around. Won't be long, I'll be at that stage myself. And this little monster is a moulding, probably for a very large stately home, that fits in the corner between the ceiling here and the wall here. Obviously, that angle between there and there is a right angle, and all this surplus wood has just been cut away. So, in summary, prisms are important for 3 reasons. Reason number 1, they give the examiners a very good opportunity to write some nice juicy questions for you to solve during your GCSEs. Reason number 2 is that they are easy to manufacture if you have the right equipment. And reason number 3, you will find them in many structures all around us in our environment. You'll be very surprised places that prisms actually turn up. So keep your eyes open as you walk around, particularly if you go to places like timber yards, builders' merchants, garden centres, and you'll find thousands of prisms in all sorts of places you probably never even dreamed about.